Hello everyone. So today we are going to see what is feature engineering. That is one of the important topic in the machine learning. So feature engineering actually it is the process of turning raw data into useful features that help to improve the performance of the machine learning model. So it includes just a minute. It includes choosing, creating and adjusting the data attributes to make the model's prediction more accurate. So the goal is to make the model better by providing relevant and easy to understand information. So how to treat the features and how to convert the raw data into the meaningful one, that is what the feature engineering is. So a feature or attribute is a measurable property of the data that is used as input for the machine learning algorithms. So features can be numerical, categorical or the text based, representing the essential data aspects which are relevant to the problem. So for different problems the features could be the different one, so that is depending on the data that we are going to use. So, for example, in housing price prediction, features might include the number of bedrooms, locations, and property age. If we are going to consider the car model or the car's example, then the features may be color of the car, brand of the car, what is the car, is it automated or the type of the car. So all these are the features. So features could be of the type numerical, categorical, or text based. That is depending on the data for which we are considering the features. So in this diagram we can see that there are different sources. So from different sources the raw data is collected and that sources are selected and merged together to make the raw data. Then from the raw data the features could be extracted. After extracting the features, those raw data can be cleaned and transformed to make them in the useful features. After that we are going to perform some modeling techniques, applying modeling techniques, and after which we will be getting the meaningful insights which we were looking for. So that is what the feature engineering is. So where exactly the feature engineering can be used, or what are the importance of the feature engineering? So it can significantly influence the model's performance by refining features. We can improve the accuracy of the model. That means choosing the right features helps the model to learn better, leading to more accurate prediction. Using feature engineering we can reduce the overfitting. I have already uploaded the video of overfitting and underfitting, so you can go back and check the video. So if we are going to apply the proper features, then it reduces the chances of overfitting. Using fewer or more important feature helps the model to avoid or memorizing the data and perform better on the new data. So it will boost the interpretability. That is, well chosen features make it easier to understand how the model makes its predictions, and it enhance the efficiency as well. So focusing on the key features speed up the model's training and prediction process, which saves time and resources. So these are the importance of using feature engineering. So what are the different steps involved in feature engineering? The first one is the data cleansing, because the data is coming from the different sources and it is in the raw form. So data cleansing is very important. Then next is the data transformation, that we will be transforming raw data into the suitable format for the modeling, which model we want to use. So for that, scaling, normalization and encoding are the most popular operations. And feature extraction, that is creating new features by combining or deriving the information from existing ones to provide more meaningful input to the model, that is the extracting the important features. Then after extracting the important features we are going to select how many are required or important for our model's performance. So only those features will be selected, and then feature iteration means what? No, continuously we are keeping on refining the features based on model's performance by adding, removing or modifying the features for improvement. So now the next term we will be saying that steps involved in the feature engineering. So the first step is feature creation. So in feature creation it involves generating the new features from the domain knowledge or by observing the patterns in the data. So how it can be? So it can be domain specific, it may be data driven or synthetic, that is formed by combining the existing feature. That is what the first step is. The second one is feature transformation. So it transforms and adjusts the features to improve the model learning. So it may contain normalization and scaling, encoding, mathematical transformation. So third step is feature extraction. So where we are extracting the meaningful features that can reduce the dimensionality. So for dimensionality reduction, there are the most popular algorithms, PCA and many others, and over there we are going to perform the aggregation and combination as well for summing or averaging the features to simplify the model. The next step is the feature selection. So out of the extracted features, we will be considering only those features which is going to be more important for the model's performance. So for selection of the features, we will be using some filtering methods, some wrapper methods or embedded methods where the features can be selected. And the last one is the feature scaling, where we are going to scale all the features to the same scale so that they can contribute very well to the model's good performance. So in that we can see the minimax scaling or the standard scaling, which is going to normalize to have a mean of 0 and variance 1. So that is what the steps, all those steps involved in the feature engineering. So I hope I have made your concept more clear. So if you have any doubt, you can put your comments in the chat box. I can answer over there. So thanks for giving your time. Thank you.